Hey, wait up. Hey, wait up. I can't see.
Okay, we'll wait for your eyes to get used to the dark.
Ow! Why is it so dark in here?
Because we rode in from the bright lights of the city into the dark of the park. The pupils in your eyes are slowly opening up right now, so let more light in. Just wait. You'll be able to see well enough soon.
Is that why owls have big eyes, so they can see at night?
Yeah. The larger the pupil, the more light it lets in, and that's why they can hunt at night. The telescope we're gonna look through works the same way. The bigger the mirror or lens, the more light the telescope captures. Last year, they had a telescope that was big enough that I got to see galaxies. It was really cool.
Hi, guys. I am so glad you could come. I was looking for you.
I see you brought your big telescope this year.
Yes, I did.
No way. That thing is huge. And it sure doesn't look like the telescope in our science classroom at school. The eyepiece is at the back. Where's yours?
It's at the top. That's why we need the ladder to look through it.
That's right. This is a reflecting telescope, which means the light is gathered on a mirror at the back of the telescope and reflected to the front of the telescope, where it hits another mirror and the light is reflected again into the eyepiece. The telescope your teacher has is called a refractor that uses lenses instead of mirrors to gather and focus the light.
Which is better, the reflector or the refractor?
It depends on what you want to observe with your telescope, but the general rule is the bigger the mirror or lens, the more light the telescope will gather, and the brighter and more resolved the object you are looking at will be.
Resolved?
Well, to resolve an object means that you can see detail. When you look through the telescope from our school, you can see Jupiter and its 4 moons. But when you look through this telescope, you can see the bands of clouds on Jupiter. So, the better the resolving power, or resolution, the better the view, right?
Right. You have a great memory.
How could I forget? I will always remember seeing Saturn's rings for the first time, and the spiral arms of that galaxy you showed me last year.
Can I look through your telescope?
Absolutely. The whole reason I brought it here.
Wow, is that really Jupiter? And what are those stars lined up on either side?
Those are the 4 Galilean moons: Io, Callisto, Europa, and Ganymede.
Why are they called Galilean moons?
An Italian mathematician named Galileo in 1610 was the first man to see them with a telescope. In fact, it's believed that Galileo was the first to use a telescope to view the heavens. He was surely the first to record his observations.
Galileo invented the telescope?
Nope. Can you tell the story of that Dutch guy?
Sure, but let me tell your friend what it was like before there were telescopes. Prior to the invention of the telescope, everyone believed that the Earth was the center of the universe, and that the sun, moon, and planets orbited around it. Then in 1543, Nicholas Copernicus proposed a different model with the sun, not the Earth, at the center. This was a radical idea, but he had no evidence to prove it. Nearly 65 years later, in 1608, a Dutchman named Hans Lippershey took 2 small pieces of glass and fixed them in a tube, creating a spyglass. A few months later, Galileo read accounts of it and built his own. On a clear evening in January 1610, he pointed it toward Jupiter. The telescope's narrow field of view made it difficult for him to find Jupiter. But when he did, he saw 3 stars next to the planet, 1 to the right and 2 more on the left. He watched these points of light over several nights, noting how they changed their position. He determined that they were moons orbiting Jupiter, not the Earth. This became the first observational evidence that the heavens work differently than what people had imagined up to then. Copernicus' theory, that we orbited the sun, was eventually proven using Galileo's new window on the universe, the telescope. And he saw more than just Jupiter's moons. His telescope magnified enough for him to recognize that there are mountains on the moon, spots on the sun, and that Venus goes through phases like our moon. He also saw that the Milky Way was made up of thousands of stars. Now, would you like to look at Saturn?
Sure.
Okay, give me a minute. Okay, take a look.
Wow, is that real?
It's real.
Did Galileo see Saturn in his telescope?
Yes, but he only saw an oblong point of light because his telescope lacked the resolution to see the rings. He described it as a planet with ears. The Dutch astronomer Christian Huygens, using a 23-foot-long refracting telescope, revealed that Saturn is a ringed planet and discovered its largest moon, Titan.
Was his telescope as big as this one?
It was quite a bit longer, but the aperture of the lens was just a few inches in diameter.
Why was his longer?
It has something to do with how light focuses through the lens. Something about color.
Aberration. That's right. When you view a bright star or planet through a simple refractor, you see a colored ring of blue and yellow around its edges. By increasing the focal length of the telescope, or making it longer, the less aberration you get.
But I only see a ring around Saturn, and it's not blue or yellow.
That's because her telescope is not a refractor. It's a reflector.
Shortly after Huygens made his long refractors, a man named Sir Isaac Newton did some experiments and figured out that the color aberrations were produced when the light passed through the lenses. So he found a way to use a mirror to focus the light just like a lens, but without the color aberrations. Now, do you want to see some real color?
Sure.
Okay. I'll point the telescope over here to a pretty sight, Albireo A and B, a binary star system, which means these two stars appear extremely close. In fact, with your unaided eyes, it appears as a single star in the sky.
I see two stars, but they're not the same color. One is blue and one is gold.
That's because each star is of a different temperature. I learned that last year. When you look at a candle flame, you see it go from blue near the wick to almost red at the top. Each color relates to the temperature of the flame at the point. The top of the flame, the red part, is hot, but the blue part is really hot.
Right again! Newton was involved with figuring that out as well. Remember the light passing through the glass lens that created color aberrations? Well, Newton passed light through a prism and figured out the colors of the rainbow corresponded with different temperatures. The blue portion of the rainbow, or spectrum, is warmer than the red. So not only did Newton figure out how to build a telescope using a mirror as a lens, removing color aberrations, he also started the study of light, called spectroscopy. These unique discoveries are utilized on telescopes all over the world every night, even on the 10-meter mirror telescopes in La Palma and Hawaii.
10 meters?
That's like over 30 feet. What's it like looking through one of them?
Astronomers don't look through telescopes that big. They use devices called detectors. Detectors take the focused light and either image it into a digital photograph or break the light up into a spectrum. Now, a photograph can tell you a lot about an object, but a spectrum can reveal the unseen. See, when astronomers study a spectrum from a star, they can deduce a lot of information about it. By comparing the observed spectrum to those created in a lab, they can tell how hot it is. they detect what elements are in the star's upper layers. They can also observe the star's apparent motion by how much the spectrum is shifted. Have you ever heard a siren from a police car or ambulance change its pitch as it drove by?
Sure.
What you heard was something called the Doppler effect, where the sound wave was compressed as it came towards you and then stretched as it went away. This same effect can be seen in spectra of stars that are in motion coming toward or going away from the observer. This effect can also be used to observe motion in galaxies.
Galaxies? Don't we live in a galaxy?
Yes, it is called the Milky Way. But did you know that we've only known that for less than 100 years?
Why did it take so long for us to figure that out?
Before the 20th century, astronomers thought the universe consisted of a flat disk of stars with the Earth and the solar system residing in the center. An astronomer named Caroline Herschel even made a map of this disk. Because telescopes of the day didn't have the resolving power to see individual stars and other galaxies, they thought the patches of light, which they called spiral nebulae, were part of this immense disk. It wasn't until the 100-inch telescope atop Mount Wilson was built did astronomers see individual stars in the disks of the spiral nebulae. An astronomer named Edwin Hubble used this telescope to observe a special type of star called Cepheid variables, and was not only able to determine that spiral nebulae were individual galaxies that he called island universes, but that they were extremely far away. Look here. This is the closest major galaxy to ours. It's called the Andromeda Galaxy.
Didn't Hubble also determine that the universe was expanding?
Yes, he did. The expansion that he observed and later observations of cosmic background radiation in the 1960s confirmed the model that the universe was created in a Big Bang.
Is that why they named the Hubble Space Telescope after him?
That's right. When NASA launched the Hubble Space Telescope, they knew that the telescope would reveal a universe unseen by land-based telescopes of the day. See how the stars twinkle?
Yeah.
Our atmosphere causes that. And regardless of how big you make a telescope, the limiting factor in what a telescope can see is the air between it and space. So when they put a telescope in space, astronomers knew that they were in for some surprises. The Hubble Space Telescope revealed the formation of stars and planets, the magnificent remnants of stellar death. It has shown us that the universe is dynamic and not stagnant. But what it really showed us is that the early universe was different than the one we live in today.
What? What do you mean, the early universe? Isn't it all the same? How can we see the early universe if we're older?
Great question. See that star over there? That's Vega. It's about 26 light years away. That means that the light which that star generates takes 26 years to travel to us. So we see it as it was 26 years ago. Now that star over there is called Deneb, and it is 3,600 light years away.
So that is the way it looked 3,600 years ago?
That's correct.
And how old is the light from the Andromeda Galaxy?
Over 2 million years. So telescopes are not only optical instruments, they can be used as time machines. And the Hubble Space Telescope looked back to over 13.5 billion years when it took an image called Ultra Deep Field. This image revealed a very different universe than we live in today. shows small young galaxies colliding and merging to form larger galaxies, which led to the galaxies that surround us today.
So now that we have telescopes in space, astronomers don't need telescopes on Earth anymore, right?
That might have been true if they hadn't developed a process called adaptive optics. Astronomers and engineers can now measure the distortions caused by the atmosphere in real time and subtract them out before the light from an object reaches the focal plane of the telescope. Because of this technology, large aperture telescopes that operate around the world can now rival the resolution of the Hubble Space Telescope. Even larger land-based telescopes, the size of football fields, are planned to be constructed in the next 10 years and will look even further back into time.
What do you think they will see?
I'm not sure, but I want to be the first astronomer to use that telescope.
Good for you. Astronomy is filled with puzzles and unsolved mysteries.
The recent discovery that the universe is accelerating in its expansion is one that will need lots of observations to figure out what drives it. Dark matter and the physics that hold galaxies together is another one. But the one that excites me the most is that we are close to having the power to observe Earth-like planets around other stars and should be able to detect life on those planets. Who knows? Maybe you will be as famous as Galileo is today because of two small pieces of glass that he turned to the heavens, launching humanity on the ultimate voyage of discovery.